Okay, good morning everyone. Okay, so today for your HBL, I'm going to continue with acids and bases. Alright, so previously when we left off, okay, basically we talked about the reactions, okay, between acids and bases over here, and we have done a couple of examples. Alright, I hope now you're familiar with the chemical equations. Then we went on to talk about what's a base. Okay, so of course I hope you still remember what's a base. A base is a metal oxide or hydroxide. So a base that is soluble in water is called a alkaline. So for base, it can either be a oxide or a hydroxide. Okay, so base got two kinds, although mostly are insoluble, except a few are soluble. For those soluble ones, we call them alkaline. Okay, so there are only a few soluble ones if you base it on this table. Okay, SPC okay, sodium, potassium and calcium hydroxide. Okay, the rest of the metal oxides and hydroxide are actually considered insoluble, so you just call them base. Alright, so this is where we left off actually. Okay, on page 6. Okay, so base once again, there's two kinds okay, either metal oxide or hydroxide. Alright, and then there's always the soluble as well as the insoluble. For the soluble ones, we just call them alkalines. Okay, so previously, I think for those who haven't complete this, please go and complete this. Okay, chemical equations on acids and bases. Alright, so what happens is we have sodium oxide and sulfuric acid. Okay, so basically I think some of you already tried this. Okay, I have Na plus O2 minus. Okay, I think maybe I erase this for the benefit of those who are slower in last week's lesson. I think earlier this week's lessons. Okay, I'm gonna just try to do it again over here. Okay, so I have sodium oxide, so Na plus O2 minus. Okay, how you can find this is you go to your periodic table okay, and the end of the notes you can see sodium is Na plus, then oxides is group 6 okay, 2 minus. Okay, so check your periodic table at the end of the notes. Right, okay, let's go to here. Okay, then I have sulfuric acid. Acid means is H plus, then sulfuric acid is SO4 2 minus. Okay, as always you will when you write chemical equations or formulas, okay, you need the help of these 5 polyatomic ions. Okay, sulfate, the name is called sulfate, and the formula, the chemical formula of sulfate, SO4 2 minus. Then you have nitrate, NO3 minus. Hydroxide, okay, OH minus. Okay, then carbonate, like what you see in acid carbonate, is CO3 2 minus. Okay, and lastly ammonium, okay, NH4 plus. Okay, the only positive ion from this list. Right, okay, so back to the chemical equation. This is Na plus SO4 2 minus, and then water, since it's just a molecule, will be H2O. Okay, so what do I do next? Okay, step number 1 okay, as you can see, basically I write out the ions first. Okay, of course with charges for ions. Okay, step number 2, what I'm going to do now is I write the chemical formula. Okay, not before I can balance, chemical formula must be right. Lastly then is balance equation. Alright, okay, so this one I sodium oxide Na2O so the 2 comes here, the 1 it is a crisscross okay, maybe I write it this way, sorry. Okay, so the 2 comes here, the 1 comes here, so Na2O is the final answer. Alright. Okay, it's a final chemical formula. Can? Okay, for you are not sure on the crisscross method, please revise. Okay, otherwise from this point onwards, it's very difficult for you to understand what we are trying to say in chemistry. Okay, alright, next thing, I have sulfuric. So you put a plus, leave some space, then copy down H, copy down SO4 without the plus, without the minus. So the 2 will come to the bottom right of your H. And since it's H plus 1, H plus SO4 2 minus, right? So I copy down just now. Okay, the 2 will come here, bottom right of H. The 1 will come here. So 1, no need to do anything, right? Okay, oh sorry, put the wrong sign. Okay, so arrow. Okay, I'm going to erase this. Okay, next thing I have Na plus SO4 2 minus sodium sulfate. Okay, so same thing, do the crisscross method. The 2 comes here, the 1 comes here. Alright, so you have Na2 SO4. Okay, next thing. Okay, I have water. Okay, that one I don't have to do much. Okay, so I think earlier on I try with you visually how this thing works. Okay, so if it's useful, I'm going to try this again. Like for example, Na2O. Okay, what it means is actually 2Na plus. Okay, so at home you can take some blank paper if you need to draw on this. Okay, later on I'll erase it away. So don't copy on your notes. Alright, don't copy on your notes. Because you need the space for later on. Alright, you have this. So I'm going to show you, okay, using this how should I say, ball diagrams. Okay, how it looks like. Okay, then I have sulfate. Okay, write wrongly. Then I have Na plus, okay, as well as water. Okay, so what I have to do now is balance this equation. Okay, I think everything is balanced. Okay, if you look at it this way, you can quite easily say why is it balanced. Yeah. Okay, 2 sodium on each side, sulfate 1 each on each side. Okay, and then the 2H plus, and this one can this means it's balanced. 2H on the left, 2H on the right. Okay, as well as your oxygen. Okay, then I'm done with this. Right, can? Okay, you can pause the video if you want to draw a diagram. Draw it on another piece of paper. Okay, I'm going to carry on. So now I need to erase this. Okay, so next question here is okay, what happens if you have a weak base like ammonia? Okay, so a bit more special. Okay, ammonia, what happens is this. Okay, you have NH3, no need the state symbols, plus let's say acid. Okay, you are just going to get ammonium chloride. Yeah, this is what happens. Okay, right, no water, as you can see, just salt only, and in fact you get ammonium salt, right? Okay, so this kind of case, do take note, there's no water as product. Okay, that's why you didn't see I add plus H2O. Okay, very exceptional case okay, for alkaline. Okay, I think you can move on. Okay, so in terms of reactions, alkaline, okay, can react with acids to produce salt and water. Okay, this is what we known as neutralization. Okay, acid alkaline is neutralization. Okay, so we have one part over here which is for you to fill it up as well. Okay, so hydrochloric acid H plus Cl minus. Okay, sodium hydroxide Na plus OH minus, and sodium chloride Na plus Cl minus, and then you have your H2O, right? Okay, So next thing what I need to do in this case is quite simple. Plus 1 minus 1, so I have HCl plus leave some space. Okay, plus 1 minus 1, right? Easy. Same charge, easy. Okay, likewise for sodium chloride and water. Alright, then you can check okay, whether they are balanced or not. Okay, so H plus Cl minus plus Na plus OH minus gives you Na plus and then Cl minus plus H2O. Right, can. Okay, so ionic equation for neutralization. Alright, so like I say, if you want to do it a normal way, you can do it. Otherwise you can just memorize lah. Okay, I'm just going to show you the normal way how we do it. Okay, but because there's only one ionic equation in your syllabus, and that is this one, ionic equation for neutralization. So you can actually get by this problem just by memorizing. But of course you want to do it normally, from, that means when I say normally means from the chemical equation. You can watch out this part of the video. Thank you. Okay, so what I need to do is okay, break those aqueous one. Step number 1, break those aqueous state into ions. Yeah, okay, that means H plus Cl minus. So that's why I say this part down here is actually very useful, because when you need to write ionic equation, you can see the ions very easily. Okay, okay, then you can cancel. Okay, so still you will land up with this. H plus OH minus gives you H2O. One from acid, one from alkaline. Alright. Okay. Moving on okay, to the next part down here. Okay, so what's happening over here is that you get the fourth reaction. Okay, so let me maybe get some space right over here. So far you have learned the acid plus metal reaction. Okay, and by metal I mean reactive metal. Okay, that means from basically anything from Mg, okay, all the way down to all the way down to lead. Alright, because the metal reactivity series is this way, right? Potassium, sodium, calcium, magnesium. Right, okay, so number 1 reaction, you have acid plus reactive metal. This gives you salt plus hydrogen. Okay, so basically the salt will have 2 words. Alright, okay, number 2, you also have acid plus carbonate, gives you carbon dioxide, salt and water. I like to call it ACC.SW. Right, and then lastly you just learn is acid plus base, gives you salt and water. Okay, I'll just hang on for a while. Okay, this is the 4 you have learned so far, each with its own acronym. Mesh for the first one, ACCSW, until so untidy. ACCSW for the second one. The third one you have ABSW. Okay, so now I'm going to learn number 4. Okay, it doesn't involve an acid. Ammonium salt plus sodium hydroxide ammonium salt plus alkaline, okay, gives you ammonia, salt, as well as water. Okay, so we are going to look at the last reaction, ammonium salt plus this noodle. Okay, so basically ammonium salt when they react alkaline and not acid, they produce ammonia gas, salt and water. Okay, so example down here, okay, let's see, I will do one. Okay, great. Okay, so what you need to do now is you have ammonium chloride NH4 plus and Cl minus, NH4 plus and Cl minus. So copy down NH4Cl, minus comes here, 2 comes here. Wait, both is plus 1, sorry. Alright, so this one is NH4Cl plus NaOH, okay, gives you NaCl plus NH3 plus H2O. Okay, it's a ammonium salt alkaline, gives you ammonia, gives you ACCSW. Okay, so this one is triple ASW, alkaline plus ammonium salt, okay, gives you ammonia, salt and water, right? Okay. Alright, one thing is I will help you see a pattern of the name as well. Let's say it's chloride, right? Second word will be chloride. Okay, if it's sodium, okay, okay, so the name of the salt, first word from the alkaline, second word from the ammonium salt, right? Okay, so meaning to say the next one you can try for yourself is actually sodium sulfate, okay, plus ammonia plus water. Okay, so ammonium sulfate plus sodium hydroxide. Okay, chemical equation. Okay, once again, you need your 6 best friends, as in 5 best friends. Okay, ammonium is NH4 plus, carbonate is CO3 2 minus, hydroxides you need a lot probably in this case, OH minus, this one I like to call it, this reaction I usually like to call it AASW, hydroxide. Okay, then you also have, let me see, what I left. Okay, you have ammonium, NH4 plus, then you also have nitrate, NO3 minus. Okay. Alright, okay, so now let's write the chemical formula. Okay, so this one you have NH4 plus ammonium, okay, NH4 plus. Right, then you have sulfate, SO4 2 minus, plus sodium hydroxide, Na plus, OH minus. Okay, then this will give us sodium sulfate, Na plus, SO4 2 minus, plus ammonia plus water. Right, so how to test for this ammonia is this okay, sorry, haven't completed the equation. So what you get is this one you have to put a bracket. So you have NH4 plus SO4 2 minus, so you have NH4 copy down, SO4 copy down. So the 2 comes here, but I need a bracket of NH4, and then a 1 goes to SO4. Okay, then plus. Okay, this one is Na plus OH minus, so 1 to 1 plus NaOH. Okay, then the salt is sodium sulfate. Na2SO4. 2 comes here, 1 comes here. Okay, 2 comes here, 1 comes here. Plus NH3 plus H2O. Okay, so I put a 2 down here. Okay, to balance. Alright. Okay, look out. Down here the balancing a bit different. Okay, so what I'm going to do is this. I'm going to do adjustment. I have 2 sets of this. Okay, you can treat it like a ball. Okay, 2 sets of this NH. Okay, maybe I draw below. Be short space. Okay, so on the left you have 2 sets of NH4 plus. And then a sulfate. Okay, then on top you have Na plus, OH minus. Okay, then you have Na plus, SO4 2 minus, Na plus ammonia, and plus water. Okay, so when you balance, the tip here is that quite obvious. You need 2 sets of Na plus and OH minus. Together they come in one. So you balance this off, then the sulfate also balance. So what happens is you have 2 sets of NH4 plus and 1 set of OH minus. Okay, so all of them will become the water as well. Yeah. Okay, so this one you have, let me see. To ammonia to water. Okay. Alright, then now I show you a video on the test for ammonia. Okay. Okay, you might want to pause and think a while. What happens when you add ammonium nitrate to sodium hydroxide? What is the product that is formed? Okay, before we end this video, think about this point. So you'll put in the ammonium salt. Okay, at this point of time, what happens is that the reaction, you can't really see it first because ammonium gas is very soluble in water. So you got to warm the test tube to decrease the solubility of your ammonium. Yeah, so they are using a moist red litmus paper. This video is actually on the MS Teams already. Okay, so here's what you learn so far. Alkaline plus ammonium salt gives you salt, ammonia as well as water. Okay, so then look back to the start of video where I asked you to think a bit about what is the salt form. Okay, so you have ammonium nitrate and sodium hydroxide. So this one is actually sodium nitrate lah, as the salt, right? Okay, so now I'm going to go back to the notes. Okay, so this one you test with moist red litmus. Okay, you wouldn't see effervescence because it's very soluble. Please cancel this part. So what will happen is that the moist red litmus paper will turn blue, like what I've seen in the video. Alright. Okay, then next thing we are going to go into is actually pH scale. Okay, it's actually a set of number from 0 to 14. Alright, okay, so basically it tells you if a solution not solid okay, you cannot say pH of solid there's no such thing as pH of solid okay, doesn't happen. Okay, solid got no ions. Basically pH is a measure, if you want to really know, it's a measure of your hydrogen ions of the concentration, okay, of your H plus ions. Okay, okay. I sorry, I realized I missed out just now for the balancing one. What you can visualize that there's two sets of NH4 plus so this one you got to have one more NH3 over here. Okay, so NH4 become NH3 and then the remaining hydrogen actually goes to the water together with the OH, right? So one more set of water actually, so two sets of water. Okay, the O cancel out, the H I cancel out, then this one cancel out. Alright, okay, if you still got problems when we see you on Monday, you can raise it up for this chemical equation. Alright, okay, so back to pH scale. So basically pH is a measure of the concentration of H plus in the solution. So acids has pH value okay, there's less than 7. Alkaline has pH value now that is more than 7. So exactly 7 is actually considered neutral. Okay, then next thing is to introduce you to the colors of this universal indicator. Alright, first and foremost, can we change this to blue rather than bluish green? Okay, so generally we use this color coding Roy G. Beef. Okay, red, orange, yellow, green, blue, indigo, violet. Okay, red pH is around 0 to 2, orange 3 to 4, this one 5 to 6. Green, which is neutral, exactly 7. Blue around 8 to 9, indigo is 10 to 11, then violet is 12 to 14. Alright, okay, maybe on Monday you can see a demo okay, of this universal indicator on common household items like coffee, toothpaste. Okay, I'm using the paper form. So basically universal indicator of two kinds. You got the paper form or the die form okay, I use the paper form. Okay, so this one important need to know the pH and the colors, okay, when you use universal indicator. This one is important. Alright, and as well as these tests for gases are very important. Okay, yeah, right. Okay, so pH is related like what I mentioned just now to the concentration of H plus present in a solution. Okay, so what happens when pH is very low, let's say 0 okay, doesn't mean no hydroxide ions okay, alkaline are solution that produces hydroxide ions, but doesn't mean no hydroxide. Okay, just that higher H plus concentration, lower hydroxide OH minus concentration. Okay, very low lah, but doesn't mean don't have. Okay, by the way, you know alkaline will dissociate in water to form OH minus. Okay, so this is a point here that I want to make known. Alright, okay, acid is H plus. Okay, so on the other side, you have lower H plus concentration, higher OH minus concentration. Right, okay, so we can determine the pH of a given solution, okay, with the universal indicator, okay, or of course a pH probe attached to data logger is the best. Alright, okay, so universal indicator contains a mixture of dyes that comes got dye kind, also got paper kind lah. Alright, there are other indicators, okay, but I'm not going to say too much about things like screen metal orange, phenolphthalein, all this lah, okay. So this one actually you can cancel lah, not so important. Okay, you want to read out also can lah, okay. This one you can just maybe gently cancel using pencil, okay. I will not talk about it. Alright, okay, next thing, okay, also very important on controlling pH in the soil. Okay, so basically you can see different plants down here. Some grow better in pH 6 or acidic soil, or some better slightly alkaline 7.5 like blackcurrant. Okay, so we have to control the pH of soil in order for plants to grow well. Okay, let's see what can we do if you encounter, especially in areas with acid rain. Okay, then the soil will become acidic. Okay, what happens? Okay, what we can do is that we add base inside to neutralize the acid. Okay, so you have calcium oxide and calcium hydroxide. Calcium hydroxide, the nickname, okay, call it slake lime. Okay, a lot of calcium containing compounds are called lime lah. Okay, and then you also have calcium carbonate. Okay, by now a lot of calcium calcium carbonate, okay, which is limestone. Alright, then you also got calcium hydroxide, which is lime water. Okay, so don't confuse them over each other. Right. Okay, so this process is known as liming. Sometimes they'll ask you to explain the chemistry behind this liming. So what it does is that the base will react with acid and then result in the increase in the pH of this soil. Okay, so let's look at one or two N-level questions as examples. Okay, so the soil in the garden has a pH of a 6.5. Okay, so the pH of the soil is changed by adding your calcium hydroxide. So which plant needs calcium hydroxide? Okay, wait, I think there's a typo. It's calcium hydroxide. Which plant needs calcium hydroxide to be added to the soil for the plant to grow well? Okay, so pH currently 6.5, slightly acidic. So if you add this one in, bear in mind it will increase the pH. Okay, so the optimum should be something like B lah, because the rest is all, if you realize, is less than 6.5. 6 is less than 6.5, 5.5 also less than 6.5. Okay, then the other one is directly equals to 6.5. Okay, so what happens when you add the calcium hydroxide is that pH will raise. Alright, okay, let's go on to the second example. Okay, so after this will be some exercises okay, that we will be looking at. Okay, let's look at this first. Okay, so the farmer wants to grow peas, okay, in a field. The farmer tests the soil and find this soil is pH 6. Okay, so peas require soil that is slightly slightly alkaline, so you need to raise the pH. Okay, so you say that the soil's pH is 6, which is acidic, hence not suitable for growing peas that require slightly alkaline soil. Alright, okay, then chemical that they can add in, this one is liming, so we can either add calcium oxide or calcium hydroxide. Alright, okay, this one got a nickname now. So calcium oxide's nickname is quick lime, calcium hydroxide nickname is slick lime. Why I wanted to write lime water? Slick lime. Okay, so now explain the chemistry involved. So this one you will have to use this point down here. Okay, so liming, this part actually quite important to explain. Can? This part is actually quite important to explain. Universal indicator important, test for gases important lah. Okay. This one. Okay, so I will say that calcium oxide. Let's say you add calcium oxide. You say that calcium oxide will react with acid in the soil, okay, to form salt and water. Okay, or you can say, even better word, you can say neutralize the acid. Okay, so this will increase pH of the soil. Okay, alright, so after the farmer has treated his soil, it is suitable for growing peas. He shakes a little soil with water. So he tests the liquid with universal indicator. So what color will the indicator show? So you use the Roy G. Beef coloring. Okay, red, orange, yellow, green, blue, indigo, violet. Okay, so the farmer has treated soil. Now it's around maybe 7.5. So it should be blue color. Okay, blue is from 8 to 9, green is 7, indigo 10 to 11, violet 12 to 14. Red is 0 to 2, orange is 3 to 4, yellow 5 to 6. Right. Okay. Sounds like we are done with the content. Okay, so I hope you have filled up the relevant parts in the notes. Alright, okay. So get ready your notes lah before you start this segment. Alright, okay, need to fill in, not just watch. Okay. Okay. So later on, once you're done with the notes, right, what I need you to do is okay, you need to go to worksheet 23, which is given to you during IW, I believe by Miss Lina. Okay, so there's a couple of questions I need you to do. Alright, okay, first thing is you need a lot of practice. Okay, on this one. This is page 18. So this is page 18 to 22 that I need you to practice on. Okay, the instructions are already input inside your eCampus. So have this set with you. Okay, page 18 to 22. I need you to do all these questions that I take. Alright, okay. When you come back, either me or Miss Dawn will go through with you. Okay, so important you get some practice over here lah. Alright, okay. Then if I never remember wrongly, set 22. Alright, you can also try this out. Okay, this part of the question out. Alright, okay. So right, okay, but this part maybe I can go through a bit with you lah. Okay, then you learn, since I think we are a little bit ahead of time for this HBL. Okay, let's take a look at this, right, and how to balance it. Okay, so I'm going to use the balls lah. H plus NO3 minus, then this is Na plus OH minus. is Na plus NO3 minus. So go to worksheet 22. This set is worksheet 22. Okay, I'll go through some if you will. Okay, because your class missed 2 lessons, a bit behind time. So I record a slightly longer video this time round. Okay, so Na plus done. Okay, balance nitrate balance. Okay, so these two will combine to give you H2O. Okay, if you notice. So this one everything is 1 1 1 1 1 lah. So no need to write anything. Okay, can. Next one. Okay, let's look. This one is Mg alone. Then I have a H plus as well as a Cl minus. Okay, then this one I have Mg2 plus and 2 Cl minus. Then this one is 2H. Okay. So you realize immediately there's 2 chloride on the right and 1 Cl on the left lah. So basically you need to add one more set. Okay, to balance. Chloride balance. Mg balance. Okay, then H balance. Okay, but what I need to do, because now there's 2 set, 1 set here, 2 set here, right? Okay, I need to put a 2 for the HCl to represent is 2 sets of HCl. Okay, can. If okay, then I'm going to erase this part. Okay, because I need some space for the next part. Okay, next part. Okay, change the one color of the pen. Okay, so this one you have O H2O, 1O2H, then a Mg, and magnesium oxide, Mg2 plus, and the O2 minus. So this one is H2. Okay, so now the H balance, 2H on the left and 2H on the right. Oxygen 1 1 balance, then Mg 1 1 balance. So everything 1 1 1 1 1 for this one, balance. Okay, next one maybe a bit tougher. Okay, next one. You have a S and 2 O. Okay, SO2 and then 2 oxygen. Then over here you have 1 sulfur, 3 oxygen. Okay, 1 sulfur, 3 oxygen. Right, okay, so now you realize there's this problem. You cannot just simply add 1 O down here, right? Okay, just to balance the O. Okay, it doesn't work that way. Okay, so what we need to do now is, what I propose is, okay, let's have another set of SO3. Okay, then I put a 2 down here. Okay, because there's 2 set. Okay, then as a result, you realize there's 2 S, right? Okay, so over here I have 1 more set of SO2. Okay, so now the S and the S can balance off. And then you see, on the left, how many oxygen? 1, 2, 3, 4, 5, 6. On the right, 1, 2, 3, 4, 5, 6. Steady, Okay, all balance here. Okay, put a 2 over here, SO2, to balance everything. Okay. Alright. Okay, let's look at part V. Okay, then you have Na plus, OH minus, H plus, Cl minus. Okay, then Na plus and Cl minus, and then H2O. Okay, so I see. Okay, Na plus, 1 on the left, 1 on the right, settle. Chloride, 1 on the left, 1 on the right, settle. So these two combine to give you H2O. So everything once again is 1 1 1 1 1. Okay, a couple more to go. Okay, before we are done for this HBL. Okay, I hope so far it has been great for you, HBL. Okay, so I have 1 Ca2 plus. Okay, bracket OH2 means 2 hydroxide. Okay, and then I have H plus, Cl minus. 1 H plus, 1 Cl minus. Okay, then you have Ca2 plus, Cl minus. Okay, okay, right. Okay, currently is this way. Okay, CaCl2 means 1 Ca2 plus, 2 Cl minus. Okay, so let's try to balance. Okay, immediately I will balance the chloride . put one more set of HCl. Okay, then you need to put a 2 here. Chloride balance, Ca balance. Okay, so next thing you realize there's two sets of OH minus okay, so the yellow one is one set okay, the green one is another set. Okay, you realize there's two set. Okay, so you need two water okay, then you can see why it's balanced H 1 2 3 4 4H 1 2 3 4. Okay, oxygen 1 here, 1 here, 2, 1 on the 2 on the left as well. Okay, so put a 2H2O here. Alright, and we are done for this one. Okay, I will erase this, okay, because I need a space for the next one. Okay, let's go to the next one. Next one is you have K plus OH minus, and then sulfuric acid that means 1 sulfate, SO4 2 minus, and then 2H plus. Okay, next one you have K2SO4. Okay, so 1 sulfate, then 1 water. Okay, let's see. What shall we do? Okay, first thing I'll do is settle the K plus first because 2 on the right, 1 here, 2 here. Okay, one more set for me on the left, one more set of KOH. So K I am balanced, sulfate balance. Okay, so I must put a 2 here because I got 2 sets of KOH now. Okay, okay, what happens next is you once again you have 2 set of H plus and OH minus first set yellow, second set green. Okay, so I need 2 water once again, okay, to balance this thing nicely. Okay, 1 2 3 4, 1 2 3 4, then 2 oxygen 1 2 3 4. Okay, 2 sets of water. Okay, so don't forget to put a 2 here, right? Okay, if okay, I'm going to erase this as well as this. Okay, so I got some space. Okay, but VIII. Okay, so now you have sodium carbonate so CO3 2 minus, Na plus, Na plus. Okay, Na 2 CO3 means 2 Na plus, 1 carbonate. Then you have a H plus and a Cl minus. Okay, then Na plus, Cl minus. Okay, then CO2. Okay, need to squeeze a bit not enough space. Okay, so this one you got to watch out a bit more okay, slightly tougher. Okay, first thing, there's 2 Na here 1 2 okay, so I definitely need one more set of NaCl. Okay, so I'll put 2 down here. Okay, so as a result, I got 2 chloride 1 2 on the right. Okay, but left side only 1, so I add one more of HCl. Okay, so chloride balance but I need to put a 2 here. Okay, next thing, you see CO3, right? CO3 got 3 oxygen actually got 1 2 down here. The third one is here. Can 1 2 3 third one down here. The carbon is over here, right? Okay, balance and then the 2H. Wait just now a chloride balance. Okay, I should strike it out. Okay, then the 2H 1 2 on the right 1 2. Okay, can. Okay, so 1 2 2 1 1. Okay, done. I need to erase this. Okay, last one for this page. Okay, I have a Ca2 plus carbonate CO3 2 minus. This is H plus, Cl minus. This is CaCl2, Ca2 plus and 2 chloride then. Okay, and then 1 carbon dioxide and 1 H2O. Okay, let's see what can we do Okay, chloride immediately 1 2 on the right. I need to do another one. Okay, then I got 1 2 2H. Okay, calcium also balanced, 1 here 1 here. Okay, then CO3 becomes CO2, then the remaining oxygen here. Okay, then I think this thing is balanced. Okay, last few over here Okay. Alright, let me squeeze in this one. Chlorine, Na plus 1I, Na plus 1Cl minus, and then 2I. Okay, so this one I need to put one more set of the I. So I have 2. Likewise, because 2 chlorine on the left, I got to one more set of this. Okay, then it's balanced. Can? Okay, if okay, I erase the bottom so I got space. Okay, next one I think can see lah. You should be able to see. Ca2 plus, O2 minus. Okay, then this one is sulfuric acid. SO4, 2 minus with 2H plus. Okay, this is calcium sulfate, 1 Ca2 plus. State symbol change for me, actually solid. Then this one sulfate. Okay, so sulfate balance, Ca2 plus balance. Then H2O 2H, 1 here, 2 here, 1 O. Okay, everything 1 1 1. Okay, last one let's see. You have 1 calcium, 1 water, 1 Ca2 plus and bracket OH2 that means 2 sets of hydroxide and 1 hydrogen. Okay, let's see. So on the right you got 1 2 3 4 hydrogen. So on the left you must increase, get another 2 more set. You only have 2, so as a result 2 water. Okay, then 2 oxygen, 1 here, the other 1 here. The oxygen must balance. Okay, then lastly is obvious the calcium. Okay, so now you are balanced. Okay, and then for the bottom you can go and try just A and B lah. Ionic equation of neutralization is just this way. If you really cannot do it, it's fine, because there's only one ionic equation that I can test you in the N-level syllabus, which is this one, ionic equation for neutralization. Yeah, right? Okay, so how I do this is I break all the AQ. Step number 1 okay, maybe I write a step break the AQ ones into ions. Okay, what I need to do now is I break this one. All the AQ solid, liquid, gas, just remain and copy down. Remain the same thing and copy down. Okay, later I show you how to do for H2O. Okay, so H plus NO3 minus plus Na plus OH minus. Okay, done. On the left side. Right side become Na plus NO3 minus gives you H2O. Okay, so your choice. If you want to break it down this way, it's a bit longer I feel personally. If you really cannot go through the step, just memorize this This will be the final answer for neutralization. So neutralization means you have to be acid plus alkaline have to be okay, this one has to be acid plus alkaline. Okay, step number 2, go back to step number 2, cancel the spectator ions Spectator ions means those that are on the left and on the right. Okay, on left and right, exactly the same thing, then you can cancel. Okay, nitrate, Na plus. Okay, then third step copy down what is left. Okay, alright, so which is actually with state symbols ionic equation must have state symbols. Okay, they won't tell you to put state symbols, but you must put. Okay, alright, I just write a comment ionic equation must put state symbol, no matter what. It's by default must put state symbol. Okay, alright. Okay, then I come to the end for today's HBL. Remember to do okay, this one worksheet 23, page 18 to 22. Okay, very important. You need to get a lot this one is important must practice. Important must practice. Okay, you need a lot of practice on chemical equations. Okay, Like I say, if you don't understand things like what HNO3 is nitric acid, H2SO4 is sulfuric acid, you are going to have a lot of problems as we move towards your end of year, or even in sec 4. Okay, a lot of problems. Okay, please practice. Okay, all right. Other than that, have a good HBL day and then enjoy your weekend. Okay, I'll see you back on Monday's lesson. All right, complete page 18 to 22. Okay.